So on the previous video I saw that the motor case on my wrecked Yamaha R1 was busted. There is a big hole in it. It is cast aluminum, so I was like, maybe I can TIG weld it. I never did it before, but that's the reason why I got that brand new TIG welder right here. So let's weld. And now I'm gonna sharpen my tungsten. Tungsten is good now, let's put it in the torch. So I'm using a cup number 5, so my stick out is going to be 5/16 of an inch, and my CFH is going to be 10 CFH, maybe 12. I'm going to start with 10. Because I want to use 220 volts, I'm using the outlet that is for my electric stove. I bought this adapter right here from AC Works. I'm going to put the link in the description. Okay, so I think I'm ready. I got this little coupon of aluminum in 1/8 thick. This is gonna go here. This is connected to the ground. I got my torch right here. If you want to look cool. Okay, well, let's go. It's the first time I TIG weld. Here goes nothing. Pretty terrible. Okay, well, everything works, so that's great. I think I'm too high. My torch height is not good. I'm too high, I need to relax. Let's do it again. Here you go. That's what it looks like right now. Not pretty. So, yeah, well, I gotta practice, huh? Okay, this isn't so bad. So that was pretty terrible at first. I'm gonna try to show. I got a lot of black here. That's my first trial. First, second, third right here, the black one. And then everything else is with a different tungsten. So this is the very last one. It doesn't have a crater. And this one is the second to last, doesn't have a crater. I was very close to the edge. I burned the edge a little bit. This is pretty hot. So all in all, I think it looks pretty decent. It's of course not the best at all. What I'm gonna try to do right now, I'm pretty happy with my fitter. What I'm gonna do is I'm gonna take another coupon right here and I'm gonna try to weld them together. I know it may be a little optimistic right now, but this is what I want to do. Okay, I'm gonna get a break on welding because it's getting frustrating right now. I have the tool to take the engine out of the frame. I'm gonna use that tool, take the engine off, and then I can go back on welding. so the engine is out. I got my bike without an engine right here, and then motor is right here. I propped it on some 2x4s, scrap 2x4s that I keep exactly for that. So it's kind of sturdy right now. It is upside down, and I got, you know, like bad surprises on that bike. It's just like every day, every minute. I'm gonna show you something. When I look at inside the case, now that the oil pan is out, we're gonna see something. Let's check it out. Yeah, I'm trying to point at all that dirt that you see in the middle of my halo here. If you look at the bottom right here, you see how dirty that is. Just gonna try to play with the light so you can see more. But that's basically what it is. So I'm not gonna put that engine back together like this. Like, there is no way. I don't really know how to clean it when everything is put together right here. So this is gonna come apart. What I'm gonna do, I'm just gonna try to show again here. We got some part right here. You see that right there? Like, I don't even know, is it some gravel? No, it's a piece of aluminum right here. If I yeah, get that. But yeah, just to show how dirty that is inside. There is some dirt. There is some junk from the road. There is some aluminum parts from the oil pan that is broken. There is a bunch of everything, and if I wanna have an engine that works correctly, I am definitely not gonna put that like it is right now. So what I'm gonna do is I'm gonna take the lower case. The lower case is on top right now because the engine is upside down, and that's the part that's broken, right? So if I show you that right here, that's the lower case. And we know that this here needs to have a part to have that mating surface flat again. I'm gonna have to refill some material right here. I'm gonna have to weld over here. I'm gonna try to show a different angle right there. Boom, we need to do that. We need to do here. And then we know that we have that problem over here with that little part that needs to be welded. And at first I was really like, I'm gonna do everything with the engine together, the way it is right now. What you see here was like, I'm gonna be able to weld. Now that is kind of flat, I'll be able to weld over here, and then I can wedge it a different way when I need to go there. What I'm seeing now is like, it's so dirty. There's no way I'm gonna put that engine back together and just be happy with it. I'm gonna take this part out, which means I need to take the oil and water pump out, which is this assembly right here on the engine. That goes for the water right here, I mean the coolant, right? And then here, that would be for the oil tube right here. So there is two different functions to that pump. There is oil and there is coolant. Anyway, I need to take that out. I need to take a bunch of little things out. And then finally, that part is going to be completely out of the engine. We can see the mating surface for this one would be right through here. And we're gonna see it. I'm gonna take it out, and it's gonna make it so much easier when I finally get on my welding table that I made myself, because I'm finally gonna have that part. I'm not gonna be playing with an engine is what I mean. I'm not gonna be like, this is a heavy engine, I need to wedge it, I need to prop it in a way that I can weld. And it's gonna get hot when I weld. I don't want to damage anything. Well, all of that is gonna be out of the equation now. It's gonna be all good because I'm just gonna have that part. So I'm gonna stop procrastinate and I'm gonna get to it right now. This right here, the crankshaft. As you know, I don't have the keys for the bike. I don't even know if the motor run, if it's seized, if there's any problem with it. So what I'm gonna do right now is I'm gonna take advantage of having that bolt right here and try to move it, just to see if the engine works. I mean, when I say it works, if it moves freely and if there is nothing that's making a weird noise. So let's go ahead and do that. All right, that's a great surprise. It sounds good. Everything, there is compression. I can hear the oil pump. I can hear things working correctly, and there is no like hard point as I'm turning it, and I feel like I do the full rotation. So it's good. It's awesome. That is good news. So here we are back again on my welding table. We have the lower crankcase right here. It's pretty dirty. I got some cable right here that I need to remove. I want to remove the junk, the oil that I have on it. Cast aluminum is apparently very difficult to weld. I didn't know that. Aluminum is difficult to weld. Then cast aluminum is like one notch above. I didn't know all of that. This is pretty complicated. I tried, when I was doing my little parts of aluminum, I tried some cast at some point. It was a disaster because that cast was very, very dirty. I wasn't able to weld it. It's not even like the result was bad. There was no result. Like I was making like big blobs and burning the material, but I wasn't welding. This cast right here, to me, looks a lot cleaner. And I would assume like it's a performance engine on a very modern bike. I would really assume that to be a very pure alloy of aluminum. So I'm gonna really clean around here, the paint, the oil definitely. I'm gonna keep going on some experimentation with the small parts of aluminum. I need to do that before I jump onto this. When I feel more comfortable, I will go on this one. I will try to refill some aluminum right here. I will bring the camera closer. We'll really see what's going on. And yeah, by the end of today, maybe like that's done, you know? But I need more practice. So let's go on to the cleaning and then do some more practice welding. I don't know if I'm ready, but I want to try. I don't really know if I can get better with just my little parts of aluminum. I feel like I need to go in the nitty-gritty and really try on a real part and see how it goes. I don't even know how the cast is going to behave. So let's go. Let's do it. Okay, so not quite 3 years, but I spent a lot of time on that crankcase right here. What you see right now is after days of TIG welding, filing, definitely using that carbide burr that really helped me because I made some mistakes and I had to grind everything off and start again. And the big takeaway, if you have to do cast aluminum, any kind of welding on cast aluminum, be very patient. It's going to be time consuming. It's not going to be fast, and don't rush it. Be prepared to be frustrated because that thing is not going to happen in a matter of minutes or hours. What I had to do was to weld, try to weld, get that puddle, put my feeder rod, try to just have that little movement of going back and forth to really blend it in, and then wait. Then back off, wait for 10 minutes, go clean it with a brush, and then go back at it. Let your part cool off, because otherwise you're gonna have your whole thing collapse. That's hard for me to explain, and I heard people saying it on videos before because I consumed a lot of videos trying to get that experience from other people. It definitely happened. You have that oxide layer on top of aluminum. As much as you clean, it is on it. And if you melt the aluminum, the oxide layer is not melting, so it's like a skin, and it really looks like a skin when finally the whole thing collapses, but the skin holds it. But the inside the skin is just completely soft. It's like liquid that's inside. It becomes liquid because you reach the 1200 Fahrenheit, I think that's what it is, for the aluminum to melt. But that layer melts at a much higher temperature that you will not reach, and you don't want to reach it anyway. I had to grind it off. I had to use that carbide burr again. That was a lot of work. Now now that I said what just happened to me, and it took a lot of time, and you have to be very patient, and you have to just keep cool. What I'm gonna do is I'm gonna bring the camera, I'm gonna show you exactly what I did. Welding cast aluminum, from my experience now, is very complicated. This is not easy. This is definitely something that I should have done after being very comfortable TIG welding steel, carbon steel. And this is not the case. I've never done TIG welding on steel. I've just done it on some aluminum and then some cast aluminum. I was to the point that it was so complicated, so frustrating, so difficult for me that after a few days, I reached out to a bunch of welders in the area. Everybody was, oh, we don't do cast aluminum. I had no choice but to keep going with my small machine that's very limited. I'm gonna talk about that machine in a different video, but I don't have many settings on this one. I'm very limited with my settings. I don't have any experience. I don't know exactly what I'm doing with that. This is cast aluminum. It's complicated. People, professionals that charge money to repair your parts are like, this is cast aluminum. We don't do that. Good luck. So I kept going, and I'm so glad that the welding for that part is done. Alright, so here it is. You remember there was a big hole right here. There was a big chunk of material that was missing. So what I had to do was to weld something right here, and I'm really proud of that weld. So it goes right there, and then I had to refill with a lot of filler rod right here to just build up, have that big build up where I'm finally going to be able to drill, tap, and have my screw going right here. The same goes for that corner right there. I had to refill. Remember that little part that I found on the bike, and I was so happy, and I was, oh, it's gonna be very easy to TIG weld on it. It's gonna be done. I'm even not gonna have to tap it again because the threads are still on it. This doesn't happen like that, or maybe I didn't know how to do it, but when you TIG weld, that part being so small compared to the rest, that part that I put on it got so hot. It just completely melted. I had to grind it off again, and then what you see right now is only filler material. 4043 for people that want to TIG weld, that's what I used. I used 4043. And then what I had to do was to grind a whole lot of grinding with a carbide burr to make it clean and the filing, and then to make it kind of flat. But again, this is not completely flat right now. I used that thing right here that's really for body work on a car. This is 400 grit, and well, that's, you know, pretty basic. You try to make it super flat all over. It is very clean right now. It is not completely flat. I also want to mention that in the inside of the corners that we can see right here, and then the other corner right there, there is buildup, and I made it super strong. I would argue right now that those corners are stronger now than they used to be stock. I put a lot of material. I want to make sure that that thing that I just made that took me so long is gonna work, is gonna be strong, it's gonna hold up, and that bike is gonna run perfect. Now I have received that oil pan, and this is the one that's gonna go on the bike. So when I line it up completely, I am pretty close to have something flat here, but I still need to have a whole lot of work. Now, to make it flat, completely flat, I have two options. The first option is basically what I've done for a few hours already. I'm not gonna file anymore, but that's what I did. So filing, and then sanding here, the corners. It's all great. It takes a whole lot of time. Anybody that knows me knows I'm all about time efficiency. This is not efficient. It's gonna take me hours. So what I'm gonna try to do, I'm gonna go to a machinist. I'm gonna bring that crankcase. I hope he's got a milling machine available and can take the job. I'm gonna try to do that. That way, in an hour, the whole thing is completely flat, perfect, and then I can move on to something else. Because otherwise, I'm gonna spend a lot of time doing it. So let's go do that. I am one happy guy. Oil pan on the crankcase, and the crankcase is finally completely flat. So let's check it out right now. If I use my ruler right here, that is flat, and I put it right where I did the welds, right here, there is no gaps between the mating surface and my ruler. So the entire thing is flat here, and then I took it for the entire length of the crankcase here on the mating surface again. And let's put it, yep, no gap all the way. It is super clean, super happy. This is done. The entire surface has been done, even those two right here. So anywhere I put my ruler, there is no gap. It sits really flat. It's not wobbly. The entire thing is good. That is done. So planing is done. You saw he was using some dye. I've never seen that before. Super cool. Really helps for the visibility of really making sure that you hit the entire surface. Very cool. Never saw that before. Then he did the drilling right here in that material that I welded here. So the drilling was done and the tapping was done too. We got the same threads, which is a metric system. It's M6x1, what we have here. And we drilled on those two a little less than the other ones. But I'm gonna explain that in a second, that it's no problem. So just making sure everything screws really nicely. Yeah, that's beautiful. That thread is great. I had to clean it up a little bit, but it's good. So just to make sure, you know, that's the one here. And then this one, I'm just gonna leave the screw right here, and we're gonna take a measurement very quickly. So I'm bottoming out right now. I can't go further, right? And I'm gonna measure the distance between the mating surface and the bottom of the screw right here, the head of the screw right here. So we have 10 millimeters, I'm talking in millimeters, okay? Just bear with me. So we got 10. We just need to make sure that that distance right here is less than the thickness of the oil pan where the screw, where the holes, the screw holes are. So how much do we have? We have 13, and it should be the same, 13. So we're all good. That means that when I'm gonna tighten that whole oil pan on, I'm not gonna be bottoming out right here the screw before I'm even touching on the surface and really trying to tighten it. So it's all good, it's perfect. The only reason I'm talking about that again is because the depth of those holes is slightly less than the other holes. So why did you drill less than the other holes, by the way? It's just because I'm trying to get as much aluminum as I can from that whole thing here. The more I drill, the less aluminum there is, the more fragile it is. I don't want that. I want the thing to be super strong. And again, when we look at that crankcase right here, and we look at the corners right there, and then right here, you can see how thick it is compared to here, and here, just the thickness of the wall. So I am very happy, I'm super excited that crankcase is finally done with the welding on this. What I need to do next is cleaning it, then priming for paint, and then I can finally put it back on the engine. That's gonna be in the next episode. If you wanna see that, if you like to see me just rebuilding that Yamaha R1 and many other projects, consider subscribing to the channel. Activate your notification, this way you know when I post a new video. I see you in the next one, and meantime, keep building.